Okay, in this question, right, you are told that a tank contains, okay, this is 4 pounds of salt dissolved in 100 gallons of water. So at the start, we did one question before this, right? Did we not? No, this is a fresh question that I missed. Okay, so this is a scenario made that in order to imagine what's going on, you might want to draw a tank. Okay? So at time t equals 0, right, you are told that there are 4 pounds of salt. Should you say there are 4 pounds of salt, or do you say there is 4 pounds of salt? Anybody wants to correct my grammar? Okay. Anyway, in that case, I'll just decide there are 4 pounds of salt. So imagine in this question, if we were to let x be the amount of salt at time t. Okay, let x be the amount of salt at time t, and then at time t, and t is a time in what? Time in minutes. So therefore, at time t equals 0, x is actually 4 pounds. Now it says you are adding water at the rate of 5 gallons per minute. So there's actually an input. What's the input like? You are told that it's at the rate of 5 gallons per minute. And at the same time, each gallon contains 2 pounds of salt. Which means per minute, how much salt are you adding per minute? Per minute, you are adding 10 pounds of salt. Agree with me? Because if every gallon carries 2 pounds and you're adding 5 gallons, right? So that means in 1 minute, you are actually pumping in 10 pounds of salt. And then you are told that the mixed solution is drained from a tank at the same rate. What do you mean by same rate? It means it's pumping out at also 5 gallons per minute. Right. So if we let x be the amount of salt in a tank at time t, you will therefore realize that this x actually fluctuates. How much or how does it fluctuate? There's always the incremental rate, and there's always the decremental rate. Okay. Oh, they use y. Sorry. In the scaffolding they use y. Okay. So so let me change the letter to y just to conform. Y. Okay. So without looking at the scaffolding below, at this point, I want to impress on you that in this question, it is hard because it has a mixture of incremental rate and a decremental rate. And it's so harder than what you think because, well, the incremental rate is quite easy. If I ask you, what is the incremental rate, Ken? What's the incremental rate of y? You will say is 10 pounds per minute, because our discussion earlier on yielded this finding that every minute 10 pounds of salt is pumping. So the incremental rate is easy. But for the decremental rate, is there someone who can tell me what therefore is the decremental rate? And to do this, you must first and foremost try to write down the concentration. In the case of input, the description tells us that the concentration is 2 pounds per gallon. How about in the case of output? What do you think is the concentration of the solution that's been pumped out? How much of salt per gallon? In this question, you realize that because 5 gallons is pumped in and 5 gallons is pumped out at any one time, the amount of solution in the mixture, right, is always fixed at 100 gallons. Right now. And at any time t, this is the amount of salt that we have at any time t. So based on this, right, the concentration of salt that's been pumped up is actually y over 100 pounds per gallon. When I write down this concentration, right, there's a catch, the catch is we have to imagine that this concentration is spread uniformly throughout the whole tank. In the actual engineering work that's done in industry, right, they probably have a stirrer that keep on stirring the solution so that the concentration is assumed to be uniform throughout. So that we can imagine that when you pump out 5 gallons of solution out from the tank per minute, you are in effect pumping out how much salt? You are in effect pumping out 5 times y over 100 pounds of salt per minute. This is the difficult part. This is actually new to many people who have not done it. So now you know, actually the concentration depends on y. At the same time, when you pump out, right, the decremental rate in this case also is dependent on y. So with this discussion, we are now ready to take on the question, and let's look through, okay? Okay, so it says, form a differential equation based on the overall rate of change of the amount of salt in the tank. So our discussion yielded this. What do we have? Our discussion would yield that dy dt is equals to, remember the input, right? The input we discussed was 10 pounds. So it's 10. For the input is 10. Minus output we have agreed is 5y over 100. So this is actually the differential equation that is asked for in step 1. Let's see, okay? All the discussion here accumulate to the same equation that we have written down. The same equation. So those boxes above is to help you to see things clearer, right? Those things in front here, right? Those things in front here is to help you see things clearer, right? But if you have understood my discussion, you would agree with me that the DE turns out to be just this, right? So this is how DE works, You study a physical phenomenon, and then you try to actually write down a DE that defines how things fluctuates. This is the same for any kind of other work that you do. It could be in the finance also. No? In the finance, actually people use this. Those who are able to capture all the factors of the stock market, and therefore model the whole fluctuation using a DE, right? And then using known method to solve the DE, right? You can really tell the stock market price the next minute. Although last time I shared with you, if you know things one day beforehand, right, it'll be fantastic. But in reality, like, you just need to be ahead of time by 1 minute will do. In the stock market, there are this thing called trading using AI, or using So you always retail investor like me and maybe your parents are always having the information maybe 5 days later. You're always lower. When a person comes up to talk to you about certain stock, right? How you should buy or not buy, actually that piece of information is very outdated. So you got to listen to this information with a pinch of salt. You don't jump to say, but the guy say, based on this, the stock market is going to rise. You can believe him at face value, you're too. Because some of these people, I was told, I'm not sure it's the truth. They are paid to say like that, I'm not sure it's the truth. Okay, in any case, so this example goes to show that if you are able to model the entire phenomenon as a DE, you can now literally solve the DE. Now, how do we solve the DE? The D that we had was actually this, right? Was 10 minus 5y over 100. Okay, let's hear from Chen Yen, right? Chen Yen. How do you think we can solve this DE? Of course, we can first and foremost tidy up a little bit. This is going to be 10 minus y over 20. Is it correct? Is it correct? Okay. So now, Chen Yin, how do you think we solve the D? How do we separate the variables in this case?
Just divide by 10 y over 20.
You're trying to say this, right? You're trying to say this. If you read my mind, Chen Yin, what do I have on the right hand side? I have deliberately kept the minus on the left. Chen Yin, do you know why? It comes in handy, right? It comes in handy. So if I'm able to solve this DE, right, you will be able to actually determine how much salt is in that solution over the next few minutes. And that's phenomenal, no? Because you can predict, you don't have to guess, you can predict accurately, Yeah. So at this stage here, we do not want to use the conditions yet. We want to rewrite. Okay. Upon rewriting, let's hear from Jing Wen. Upon rewriting, what do you think we will get? Jing Wen is right or wrong? Jing Wen or Jing Wen? Jing Wen. Because if you say Jing Wen, right, it becomes a vowel. Jing in Chinese, Jing, right? Jing Wen or Jing Wen, Jing Wen sounds like a vowel. Okay, Jing Wen, she's Jing Wen, okay? Okay, in any case, say, you will say is 200 minus a e to the power of. So I leave you to fill in the in between, the gaps leading to this line. And then using the condition that at t equals 0, how much do you have? It's 4, right? Okay, using the condition, when t is 0, y is 4, right? Using okay, Zoe, what do you think is A? You say 196, right? Right. So you have a solution for this DE, which means I can now use this DE to plug in the value for t, and I can know for sure. Yes. Here is it. Here is it. Oh no, I made a mistake, is it? I think so. Sure. Guys, I made a mistake, no, I'm so sorry. I let's retract. But it's okay, no, I can do it very quickly. Thank you, Ken. I was testing your numbers. Yeah. Yeah, I made a mistake, terrible mistake. I'm sorry about it.
I think you Chap kan.
Yeah, I'm silly. Okay, so if you correct the mistake, I think that this should be the case. Alright. So your solution to this DE is like this. If you were to sketch a graph of this DE, it will look like this. No, it will look like this. This y and this time t. If you sketch a graph, this graph looks like this. It look like this. And from this graph, you can see therefore that in the long period of time, the amount of source solution will taper towards 200. It will not go beyond 200 based on this calculation. It will taper towards 200. Nice, right? So with math, you can do wonders, right? You can do wonders. So there's another part of the question, I think. What does it ask for? Oh, don't have any. Okay. So I wrote back to let you jot down. So it's shorter than what we planned for. So step 2. Let me know if I start at step 2. No, I'll gladly do it for you. It was interesting yesterday that where we were seated, I was with Aiden, there's a group of the RGS girls, they sat right in front. And the group of RGS girls who sat in front, right, they won big time, they won quite good prizes. I'm not sure Aiden noticed. So I was thinking in my head, they must be very confident, that's why they sat right in front. Yeah. I'm not sure, I'm just second guessing. They sat right in front, they cheered for a friend when friend went out to get prizes. So the group of girls around there, they won. I remember both groups won gold medals. Both groups. Okay, with this in mind, anything to ask? Okay. Okay, the next question about lake. You want to try this question now, no? Okay. A lake contains 1 million liters of water. This question is actually somewhat a repeat of the earlier one. So after doing the earlier one, this question is meant for you to practice. Give yourself that 5 minutes to try to do this question because it's really worth it, to see if you have learned well the last question. Because you need to learn how to do the last question in order to do this question, which is quite similar, right? Quite similar. You like to know that maybe you didn't know, no? We cannot anyhow discharge water into the environment, not allowed. Yeah. What's happening in Japan is they are trying to discharge the contaminated water. They claim they clean it, I know. Seriously, no. One day I will just be imagining, you'll be eating fish with 2 tails because of contamination in the ocean, right? And then with the radioactive substance, maybe the genetic structure of fish in the ocean will change, and they will have 2 tails and maybe 3 eyes, kind of thing. I hope that won't happen. If that happens, it's like quite scary. Okay, yeah, sure, great. Are you very tired or something?
Yep.
Yes.
Was there a bus to bring you back to school?
No, we had to fly back.
We had to fly back to school.
Last time when I reached home, right, my daughter and I started having dinner about 8:15,
We started having dinner at 8.
8
Madam, we bought dinner
We
at
bought dinner at 7:45.
Yeah, about same, yeah. It was very late, My daughter was waiting for me at home,
Then we had morning runs yesterday morning as well.
Okay.
Tired, just tired after tired.
Okay. But I can see Arohi is energized, She's doing it diligently now. It's just like a race, When you're running in a race, right, and you're always in front, you feel like running even faster. So Arohi is getting that so-called first position feel. Press on, let this momentum last till end of year 6. Okay, in this question, let's use similar notation. Let's use the notation y again. Let y be the amount of toxic, amount of toxic waste. At time t, and t is a time in what? In hours. And this question, right, pictorially, right, you can imagine this like the way we had just now, like a tank. You see the lake like a tank. Talking about lake, there's one lake I want to interest you know. It's called the Loch Ness Eve. Loch Ness Eve, is it? There's a place in the UK called the Loch Ness Eve, I think. I don't quite remember the name now. Anyway, it's up in Scotland. It is supposedly a place where people sighted monsters in. Loch Ness Eve. It's not called a lake. Personally, I have been there. I remember in year 2000, I went to UK. I started driving from Heathrow. Heathrow is down south. I drove all the way up to Scotland, and I visited the place called the Loch Ness Eve. I was hoping to see the monster. It was a bit foggy, you know, and a bit spooky, you know. Yeah, and the visibility was quite bad, lah. I remember that night, you know. Yeah. So maybe one day you go there. Some people there's every now and then you see reports about people sighting strange thing there, you know. Yeah, and there were scientists who were trying to go in there to pick up samples to see if they can spot DNA of a dinosaur or thing like that. Yeah. They believe there's a sea monster living in there. I didn't see it, like, gladly so, you know. Okay, so imagine the lake like a tank. What we hear here is the toxic waste is pumped into the stream at 0.01 gram per liter. It looks very little, right? Looks very insignificant. It is pouring at 300 liters per hour. So based on this, the concentration of toxic water being pumped in is, the amount of toxic being pumped in per hour will be 3 grams per hour. Then you are told that water flows out of the lake in another stream at the same rate. What's the rate? Is again 300 liters per hour. We are told that at the start it has 1 million liters. Right? 1 million liters. So because you pump in 300 liters in 1 hour, you take out 300 liters in the same hour, the 1 million liters inside the lake is maintained. Now, there again, you want to remember, you want to try to find out the concentration of salt solution that's being pumped up. What do you think is the concentration of the salt solution? We believe that the toxic. We believe that the concentration is uniform throughout the whole lake. And given that at time t you have y amount of toxic and you have 1 million liters, so altogether the concentration of toxic is y grams per 1 million liters, which therefore works out to be what? No, that in every 1 hour, right, you're pumping out 300 y over a million grams per liter. Okay, with this discussion, you want to now write down the DE governing this phenomenon, you know. What then is our DE? Based on our discussion, the rate of change of the amount of toxic inside there will be equals to a incremental rate minus a decremental rate. The incremental rate in this case is 3 grams per hour, and the decremental rate is 300 y over a million. Of course, we can do a bit of tidying up, We can tidy up, this will become 3 minus 3y over 10,000. Okay, sorry. I've gone too fast and I didn't follow the step 1 carefully. Sorry about it. I think I have jumped the steps too much. I'm going to rewrite. Okay. In the meantime, I'm going to do this. I'm going to click on this, and I'm going to move this thing away first. I'm going to move this thing away first. Park it here. Okay. So let's go back to the step-by-step help. Okay. In the step-by-step help, it says how much toxic waste enters the lake every hour. We know that there's a 0.01 grams per liter of the wastewater that's been pumped in, and then we are pumping in 300 liters per hour. So based on these two, we therefore conclude that you're pumping in 3 grams of toxic per hour. So it's 3 grams. Okay. Hence, right now, DE for this phenomenon, the DE will be, just nice. I'm going to steal my DE that I had here. Oops. Okay, my mission failed. Not to worry. Okay, I'm going to do it again. Oh shucks, the thing really went missing. Okay, bad luck for me. So it's going to be 300 y over a million. Okay. And then because it's you're right now initial value problem, right? You must also state the condition of that at the start it was pure water, right? So at the start there wasn't any toxic. So altogether, this is my DE with the initial condition given to us. Okay, okay, once again, did we talk about the word fish or fishes? What do you see? Alexis? Yeah, what happened? Are you seeing things? Okay, so now we are ready to solve this DE. Actually, it was one done just now, no? Alexis, I made a mistake. When you look down, I changed it. Then you look up, it was done.
Actually, you can see things.
So now to solve the DE, is going to be 30,000. Hey, there's a y missing here. Minus 3y dy equals to, okay, this time I want to be very careful. I do not want to make the same mistake as before. There's no minus. Right? And then this gives me minus 1/3 ln of minus 3y and then you're supposed to tidy things out a little bit, If you tidy things out a little bit, y will be equals to 1/3. 1/3 30,000 minus AE to the power of minus 3t over 10,000. Like that. So the part to getting the last line, right? I want you to try it yourself now. you must actually try yourself to get the same line as what I have, you know. Okay, let me pull this up and write a more clean version, you know, of the final solution. I'm going to write this thing as y equals to 10,000 minus b e to the power minus 3t over. Right. I have actually rewritten the constant a as a b. And because of this condition, right? Because of the condition, what is a b is going to be? Let's hear from Euler. What is b equals to? Yeah, you're right, 10,000. So therefore your y is going to be 10,000 minus 10,000 e to the power minus 3t over 10,000. So you find that based on this equation, right, when time t is very large, which means after a long period of time, how much toxic will there be in the lake? When t is very large, right, the amount of toxic in the lake will be 10,000 grams. No, 10,000 grams is 10 kilograms. Yeah. So which means although it seems quite a small quantity, at the start we are told it's 0.01 gram per liter, right? It seems very insignificant, but after a long run, the amount of toxic inside there can be as much as 10 kilograms, which is a lot, you know. So those who are very who are the green people who takes care of the environment, you want to actually show to the public that what they do in a small quantity adds up to a lot in the long run, you know. So bring up this equation. Can conduct experiment, no? That in East Coast Park, if everybody were to just dirty the place a little bit, over time the ocean can be quite dirty. It's true, no, the East Coast Park is not as clean as what I used to know. When I was a young boy, when I went to East Coast Park, like, the water was crystal clear, brilliant. But now it's not so clear. Do you know that Singapore River that runs around the town in the cities, Singapore River, it used to have a stench, you know. Government spent a huge sum of money just to clean up the river, a lot of money. Yeah. And luckily in Singapore, people are very civilized. We do not litter the drain, we do not litter the ocean, you know. In general, we are quite civilized, luckily. Yeah.
If people do like fill the drain in Singapore and like drown.
Right. So it's lucky that in this part of the world, we take care of the environment. We make sure that we do not dirty it anyhow.
Luck is not a consensus, it's more like general consensus.
Right.
And people know not to do so.
Okay, so you are told that in this part 3, it says fishes living in the lake will be poisoned if exceeds so many grams per liter. Which means the fishes will not live happily if the concentration is too high. The concentration is more than 0.002 grams, which means if this thing happens, right, y over a million is actually the concentration at any time t. If this happens, right, which means when this happens, so when y is beyond 2000, the fish will be poisoned, which means it don't need to be forever, then the thing will happen, you know, that the fish will start to die. As long as the amount of toxic inside the water is more than 2000 grams, the fishes will start to die, you know. And now to solve this inequality, right? You just plug in some in here, and then um, so you do arithmetic, no? You do arithmetic. I think it's like that. Check my calculation, no? I think it's like that. Ln 0.8, sorry. Ln of 0.8. Check my calculation. Can you do a calculation and check for me whether or not I am right? No? If I am correct, right, then the finale is t is more than ln of 0.8 divided by minus 3 times 10,000. So from there, you can find the first time that the fish will start to feel discomfort, and then eventually, I guess, die. Is this 0.8? Check for me. There's answer there. No, the calculation, the green color calculation on the side. Let's check now. Whether or not, okay. While I dig up the teacher's version, and you can actually compare answers now. Okay, y'all try and see if you work it out to see if we get the same thing. Kane, did I make a mistake? Are you calculating? Different, is it? Is my differential equation wrong? Oh. Okay, let's roll back. Okay, so Ken says you get something different, you know. Anybody else got a different D from me? How about Kurtish, who didn't try? You did? I'm sorry. Woo! Okay, Kurtish, could you verify if I am right? I'm correct? Thank you. What do you have in the end? Do you have something like this for the green color? Oh, the answer is there. 744 hours. I need a calculator. Is it correct? Thank you. Besides Arohi, who else won prizes yesterday? I'm just curious. Who? You are? What do you get again? Silver. So maybe I missed it because I went there. Oh yeah, no, I walked around the silver also. Maybe I missed it somehow because something blocked. Then they pull me away. Because I blocked their way. So Wen Kai at Arohi, is it? Okay, nice. Who? Oh, Drew. Drew is not in this class. Is not. Okay, this class. Yeah, Drew has been doing very well all his time here. No? I remember him as a math Olympian, right?
Very well with an mistake.
Okay, exceedingly well. Okay, question to raise. Anybody? Okay. Keyuan, do you think race? Are you half alive? Okay, the last day of school, I think that I can tell. Keyuan is